All right. I think this is going to be better. I put up a makeshift backdrop, which should muffle my voice a little bit. I notice it is very echoey sitting here, so I'm going to have to do a little work on that. I do have smooth surfaces, and I'm going to have to muffle it a little bit more. So if you need to turn up the volume, you're not going to get the feedback. Yeah, I've had a heck of a time getting the audio right on these, but bear with me. If I become a master, maybe I'll redo some of them. All right, continuing on, communication and navigation. Talking about radio installation. I might as well pipe in here. Okay, how would you mount a radio? Well, one way is if you have a mounting rack. That way it's in effect pre-installed to the airframe, in effect, indirectly, and you just are able to slide your radio component in and out of it. I'll call that a mounting rack. Avionics equipment is sensitive to mechanical shock and vibration and is usually shock mounted. You can't quite tell the shock mount here. They're a little easier to see in the bottom illustration. Think of it as a rubbery type material, so that it's like a shock absorber. Such mounts should provide adequate isolation over the entire range of expected vibration frequencies. When installing shock mounts, assure that the equipment weight does not exceed the weight carrying capabilities of the mount. Yeah, some of the equipment gets super heavy, so you're going to have to be mindful of that if you are installing an actual mount and ordering one. Sometimes, the mount is hanging there, or the device is hanging there. You need to give it some back support. You can't just let it lay there, otherwise it's going to bend. Gravity's going to make it bend the instrument panel front. So here they got a little strap. And it's strapped to a nearby structural member of the aircraft. And there's probably some spots already on the instrument just for that specific purpose. An avionics compartment, particularly with electronic instruments, the main guts or the control of the system is in a large component case, sometimes quite heavy. They're on these mounts that are shock mounted individually, and they're all located in they can't locate these in the cockpit, so it's in a convenient compartment where you can pretty much get to all of the equipment. They're showing 3 INS units. That's a little advanced, so we may touch on that. I guess they are touching on an INS, an inertial navigation system. That's more navigation. Yeah, INS or IRS. That's advanced navigation. We're mostly trying to talk about installation generically, which could also be radios, VHF 1, VHF COM 2, VOR, that type of navigation. But INS for large aircrafts, that's how they navigate. In effect, they're able to, fly blind just based on calculations of where the aircraft is turned and how long it went for in a certain direction for a period of time. Question. Installed radio equipment is protected from damage due to jolts and vibration by what protects the radio equipment? Is it A, shock mounts? Sounds good so far. B, spring and or vicious damper mounted racks? Not a bad idea, and there may actually be one like that. C, rubber or foam cushioning material between circuit chassis and case. No, I would imagine that could get wet. So yeah, shock mounts. It's very professional and much more effective and easy to maintain and inspect. Inspection, that's a frequent inspection item due to the nature of the material, subject to corrosion. So yeah, shock mounts. I guess there's the other answer from a different book. Yeah, these are some older slides. I apologize a little bit. There's not a whole lot more than the figures and the captions and the questions, but we'll soldier through it. This needs an upgrade on its own. Question. The addition of avionics and associated antenna systems forward of the CG limit will affect what? You're going to add something to the aircraft, and it's not going to be right on the CG limit. So what's that going to affect? The empty weight and useful load. B, CG limits and useful load. C, useful load and maximum gross weight. You'll get some of that terminology in weight and balance. Basically, when they're weighing the aircraft, they're trying to drain or deduct for even the fuel that's in the fuel cells. So they'll start off with an empty weight, which if you're adding avionics equipment, you're actually increasing that empty weight. And useful load is the difference between the empty weight and the maximum. So if you're raising the empty weight, you are lowering the useful load. And there's 20 pounds less of cargo that you can carry. So A. Terminology, after you shuffle with it enough, no problem. How much clearance from the seat bottom is required when installing radio equipment under a seat? They have to be creative with where you're going to put something. Under a seat might not be a bad place for it, as long as you can still have controls within reach of the pilot. So let's see. 3 inches with the seat unoccupied. B, no set minimum as long as the equipment receives adequate cooling and damage protection. Which that's a tempting answer. Or C, 1 inch with the seat occupied and subjected to maximum downward seat spring deflection, which actually makes more sense. You occupy it and have them jump it up, have them plop down in the seat and see if you're actually going to hurt the radio. I would probably practice with an empty radio box. But yeah, an inch clearance sounds good. There's probably a regulation, but it's an obscure thing. If you install a radio under a seat, it's like, not often. There's other things underneath the seat, so the space is probably already spoken for. They're giving us some technical information about what it means with the maximum downward seat spring deflection. It sounds like a 170-pound person uh, with a load factor of 6.6, so probably plopping down from 6 feet above the seat. I don't know. That sounds like it's in the AC second part. Coaxial cable, you're familiar with that from Comcast bringing a cable line to your house, inside the house to your television. Most of radio communication is done that way, and along with television and internet and a number of things. So you can certainly use your radios and your navigation equipment with coaxial cable. And being that it is aviation, it is of a higher standard. Inspect, look for breaks in the shielding and any kinks in the cable. It doesn't bend easy, so certainly don't force it. How do you install it? You've probably seen your cable technician install it. Basically, there's a tool. Some of the instructors may have the tool, and it's a nice little project. It is a good project, actually. I recommend it. This is being recorded while we're still teaching remotely. So, and it's not an expensive tool either. So, all right. When installing cable, be mindful of the amount of slack that you leave between two brackets. You can see by the illustration that the maximum amount of pressure, if you say push down on the center part of the wire, maximum of 1/2 inch with normal hand pressure. There's a bend ratio over here for coax cable. It says 10 times the size of the cable diameter. Also a decent project, because the FAA does like testing on some of this little 1/2 inch stuff for 10 times. And what's up here, 2 feet. So if you're going to have these brackets, have them approximately every 2 feet or 24 inches. Do not, optimally, do not route or tie them to other wire, because there is radio waves going through the coax cable. And you're going to introduce a stray electromagnetic field from the other wires. As I said, here's one of the questions. When installing coax cable, it should be secured firmly along its entire length. A, wherever it sags. B, at 1 foot intervals. C, at 2 foot intervals. Oh, we saw that, 2 foot. Yeah, this says, you can see it's an older presentation. When bending coaxial cable, the bend radius should be at least, what was the bend radius for coaxial cable? That was 10 times not 15 or 20. You basically, if you start kinking it, the center conductor will not be precisely in the exact center of the cable, so it won't work that way. And I guess they've measured it as being a bend radius of 10 times the diameter. Describe the procedure used to route coaxial cable from an antenna to a receiver. I would imagine you secure it every 24 inches. You don't hook it onto other wires. There's no bends greater than 10 times the diameter. Saggage 1/2 inch. Cable should be supported every 2 feet. Bend should be 10 times the cable diameter, and it should be routed separately from other wires. There you go. Switches, you'll cover this in deeper in aircraft electrical, if you haven't already, depending on what sequence you're taking these in. But switches used in aircraft circuits should have the appropriate AC or DC rating to prevent premature failures. This figure illustrates a typical aircraft toggle switch used in aircraft electronic systems. So there's going to be a rating. Make sure it's appropriately rated. Don't want your switches burning out. Circuit breakers, you've covered this again. Maybe that's why I'm covering it just slightly. There is an attached reading for those of you taking this in D2L under this section, which I believe covers this material in deeper fashion. This is really just the captions of the illustration. Circuit breakers should be the trip-free type and inspected regularly for proper operation. Yeah, this is definitely early work. Circuit breaker panel, often on the left, towards the left side of the pilot, maybe even down towards his knees. This is typical for a twin-engine airplane. Terminal strips. We don't have to talk much about that. Keep them clean and free of corrosion, dirt, and lint. Check for metal objects that could fall across the terminals and cause shorts. Some of them have the guards so that they can't be turned. You certainly don't want to put more than 4 on one post. And there may be another rule that's escaping me at this point. Bonding straps, particularly if you're going to use like shock mounts, the rubber, there's not going to be an electrical path between the instrument case and the airframe for any stray type currents that might come through. So you, in effect, have a connection. That's a nice illustration of a bonding strap. This is a heavy-duty one when the surfaces move, so there's continual movement here. So a normal piece of metal is going to eventually work harden and snap apart. But this braided type, you accomplish it and it's still flexible enough for continuous use. Certainly they're inspected. They're part of your 100-hour and annual inspections also. And the pilot may actually inspect it on the walk around. Okay, I'm not sure what else here. Bonding straps, that's good enough. Bonding jumpers, pretty much the same thing. Maybe it's not a strap. It doesn't get work hardened much, but it's basically the same thing. Inspect them regularly to detect breakage or corrosion. True or false? Use solder to attach bonding jumpers on radio equipment. I think that's a tricky one there, isn't it? Now I would prefer to use a little screw attached to have like a little ground to it. I don't think I should solder directly to the radio equipment, and that's expensive stuff anyway. So I would say no. The AC recommends that you avoid the use of solder when attaching bonding jumpers. Clamps and screws are preferred, and you notice this one's 2A, so it's more in the alteration methods. The other part of the true false is radio equipment is bonded to the aircraft in order to provide a low impedance ground and to minimize radio interference from static electrical charges. Certainly sounds good. Low impedance, or a form of resistance for AC, and it minimizes radio interference. Yeah, you're gonna be staving off that electricity rather than having it bounce around, and static electricity also. So that sounds great for all three. What is the purpose of a bonding jumper from a radio shock mount to the airframe? To bleed off, I'm not sure what word that, I like that one, stray currents, and which will protect the instrument itself and prevent interference. I don't know. To provide a low impedance ground return. That too. Low impedance, low resistance would be acceptable also. Yeah, you don't want to have to send it to a resistor. It goes straight to the ground or to the return. Reciprocating engines run by magnetos, which in effect are connected to each of the cylinders, providing a little spark. But you can imagine, the use of magnets, because it's not electrically or it doesn't take petroleum or anything to run it, so it basically runs on magnets. And that creates a lot of little sparks and noises. All parts of the ignition system should be shielded to prevent radio noise. On a reciprocating engine, for example, the magneto, ignition wires, spark plugs, and P leads need shielding. So you can see these P leads here are shielded. They're not your typical wire. All right, so, and the main reason you do that is not to shield radio noise. Basically, yeah, to shield, I think it's the other way around. Shield the magneto noise on the radio. Static wicks, unique to aircraft here, or static discharges. They can actually stave off static currents right into the atmosphere. Mostly because you're going at a velocity which creates contact between the wand there and the static electricity. You can read this if you're interested in corona discharge emitted from the aircraft as a result of precipitation static. It occurs in short pulses and it produces noise at the radio frequency spectrum. So they have static discharges. Another thing to inspect. They keep it away from the avionics antennas, and that's the main rule for those. Don't have an antenna right behind it. This is an example of one from one of the Canadian jets. Here's a variety of them. Some of them kind of look like it is. They're just simply a piece of wire braid made of stainless steel. Almost a homemade one there. The null field. That's part of what the null field type discharger. In effect, they are a type of static dischargers, but they discharge the null fields. Compare a static wick on the bottom with the null field discharger on the top. You can see there's obviously a difference. And the illustration kind of shows you what a null field does. It helps to reduce further noise. Oh, that's not a trivia question. I don't know. I haven't seen a question of null field type dischargers. Static wicks, probably. Or static dischargers help eliminate radio interference by dissipating static electricity into the atmosphere at A, low current levels, B, high voltage levels, C, high current levels, or I would propose D, low voltage level, which is not the right answer. All right, so basically we're talking about current. So eliminate B. That leaves you with A or C. And you also eliminate the D. It's dissipated. I would not say at a high current level. It would have to be at a low current level. That certainly... I could be wrong. Let's take a look. Yes, low level of discharge produces an extremely weak magnetic field, which is not picked up by the radio receiver antennas. So, yeah, that would freak out the antennas if you send out a strong current into the atmosphere. Okay, it looks like we wrapped up another one. Mission accomplished. Good having you. Bye for now.